We've already seen the visual object tagging tool. We've seen what it does, we've seen what it's capable of, but now let's get our hands dirty and actually go through a tutorial with the author of the VOTT tool. Now that's on this episode of Dev Radio.
Hey, and welcome to the next episode of Dev Radio. This is part 2. Sabrina, are you excited?
I'm super excited, and we're going to be talking about the VOTT tool. Do you know what that is?
The VOTT tool, VOTT. I sure do. What's it stand for?
Visual Object. Ari, help me out.
Visual Object Tagging Tool. Happy to help you out there.
Yeah.
Ari, how do you know what it stands for?
Well, because I'm one of the core developers of this Microsoft VOTT tool, and I'm happy to show you guys some demos today.
Awesome. This is actually part 2. We had you on the first show where we talked about kind of the domain, the problem that we were solving, the fact we needed a tool to do it, and the fact there is a tool. Now you're sharing your screen. You're going to show us what the tool looks like and make us masters of it.
Absolutely. And I think the best way to make anyone a master of something is to contextualize it. So before I get in deep into the tool, I'm going to take a step back and show you guys a real-world use case where we actually use this tool to do something that otherwise wouldn't have been possible. Recently, we worked with one of the largest chocolate manufacturing companies in Eastern Europe, and they had really hard, challenging problem. For them, they have this huge distribution chain of hundreds of different grocery stores where they stock their products. And they have deals with these different grocery stores across 15 different countries where they provide them discounts if they stock their products according to a certain valid policy. Now, the challenge yeah, right? And the challenge that they had was that it's really hard for them to be able to know across all these different countries whether the stores are actually stocking the chocolates as they promised. Typically, they hire these very expensive investigators who go in undercover and try to see whether things are looking good, but they're pretty noticeable, and it's very hard to scale that. So they came to us looking for a way to take a picture and know whether a set of shelves was stocked correctly or not.
Got it. So there's some marketing team somewhere that's determined if it's stocked this way, you're going to sell a little bit more.
Exactly. They do all this market research and all these things in the background, and they know that they want their chocolates stacked a certain way. That maximizes their revenue. Now, in the last episode, we talked a little bit about the difference between classification and detection. This is something that sounds and is a very traditional classification approach. But when they went back and tried to use some of the classification algorithms like ResNet or ImageNet or Inception, they got suboptimal results. And they were wondering why. And when we look deeper, I'm going to show you a little bit in terms of these examples why this is hard for them and why they were getting suboptimal results. When we look at a set of shelves here, which is stocked with the wrong item, it's pretty easy for a classification model to know, hey, these aren't chocolates, this is wrong, this isn't how it's supposed to be stacked. Mm-hmm. But when we look at an invalid picture on the left here, we notice that things are off by just one chocolate. And this is very small, very subtle signal in terms of being able to identify whether things are stocked correctly or incorrectly. And this is where we're going to use how we're going to use object detection to identify where certain items are and how to validate that they're stocked towards policy. Now, again, we respect our customers and their data, so we're not going to use an example based on their data. But what we did is, because we're open source engineers and we want to share all our learnings with the community, we built an example using the exact same setup, the exact same challenges with these sodas.
Got it. So we just switched from chocolate to soda. Both delicious.
Exactly. And here we have two sets of beverages. On the top here, we have a policy that says all the sodas need to be at the top of the image, all the juices need to be in the middle of the image, and all the waters need to be at the bottom of the image. Any other configuration, any other shuffling is wrong. Now, you can imagine this could be a challenging problem for a traditional classifier to figure out, and I'll explain why. When we look here and we look at the difference between the pictures here, we see that it's invalid but we don't know why, just looking at these two pictures. Is it invalid? We know because we know the policy, but if I didn't tell you the policy, you wouldn't know, right? Because it could be that the juice moved down here, or it might be that the policy is that this green soda needs to always be second to the left, right?
Yeah.
Or there could be some other configuration. This blue water always needs to be next to this other color blue, right? There are many different configurations or policies, and it can be very, very subtle and very challenging. So what we're going to do is we're going to use object detection, essentially as a feature extractor, and we're going to combine that with heuristics to build to get state-of-the-art results that this company was able to take and use in production.
Cool.
So let's take a step back here. And I'm going to show you VOTT. So before I get started, let me show you exactly where and how you can get started with VOTT. If you go to GitHub Microsoft in the Microsoft repo /VOTT, it will redirect you to VOTT. We have all the documentation on how to use VOTT and how it works. We can go very, very quickly and see here in the releases. We just download VOTT as well. There's support for Mac OS, Linux, and Windows. And I'll show you. We can use NPM. So I'm going to show you VOTT. We'll get it started here. The first thing you'll see is we get this screen that asks us what we want to annotate. So if I wanted to, I could annotate videos and go frame by frame, or I could annotate a set of images. And that's what we're going to do now. I'm going to pull up a couple of these images of the shelf. We'll go into VOTT, soda, and we have to give it some labels, right? We have a couple different region types, but in this case, we want to use rectangle. We could also use square, which auto fixes the bounding box. And here we're going to give us our labels, something like juice, soda, and water. The next thing we do is now we have this tagging interface. Now you'll notice that this is something that is resizable, that it scales, and when I tag, I can maximize the screen real estate by zooming in and zooming out, which is really, really nice. There are a couple different ways we can tag. We can click and drop, or if I hit the control key, I can just click 2 points. And if I do that, it allows me to tag relatively fast. But you can see that it's still relatively a lot of manual work. If I'm a little bit off, I can just reset the tag here, and I just go through it again.
Ari, how exact is exact? I see that sometimes you are right on the edge, and sometimes you're a little bit far from the edge. What's your goal?
So the goal is we want to be exact as possible, but if we have enough data, in this case, for this, it depends. You know what? Actually, let me rephrase that. The goal is it depends on your scenario. So in this scenario, we want to know where each of the bottles is in their position. If we have a little space around the bottle, that's okay. In other scenarios, you might need more precision, so you want to put in more precision. Now, every person, you'll notice, tags a little bit differently. And so as part of that, in some of the pre-processing steps when we train our model, we might shift the tags a little bit to the left, a little bit to the right, and we might have a couple of different people also tag so we can average out different annotation styles.
Interesting. Boy, that's a good little pro tip right there.
Yeah, and so you can see here that we've now drawn bounding boxes, and I'll quickly show you how we can just make it a little sharper, for about 18 objects in less than 30 seconds. Now, that's pretty good. In most tools, you have to do this long dragging process, and it takes a very long time. But imagine we have hundreds of images. That can be challenging.
Yeah.
So there are a couple of things that we can do here. Number one is we have to go through, and we have some keyboard shortcuts, and we just got to annotate. So I'm saying that here I'm giving the tags that the top here is soda. We're going to go here, and we're going to say the bottom ones are juice. We go in and do that again.
Mm-hmm.
Yep, and again, bottom one's water. And you can see, again, when we were talking earlier about this mechanical process, what we're trying to do...
This is labor-intensive, no doubt about it. For 1,000 images, this would be...
Exactly. If we can minimize this process, it's necessary, but if we minimize this process as much as possible, we'll be in really good shape. So you can see that we can go through. One of the things is we can also duplicate the tags from other frames. We can move them in bulk. We can do a couple other things to get more accurate, faster tagging.
Now, I noticed that the second picture was pretty blurry. Is that part of your strategy as well, that you don't want to have the same picture over and over again? You want to get as many variations as possible?
Absolutely, and that's why when you see that I took these pictures, I shook the cam, I did some blur. In the actual training process, we might actually do some additional what's called image augmentation steps, where we add blur, or we do some cropping, or we modify, we modify the lighting or put some filters on the image. And actually, that's something that we're going to see in future releases of this tool, is the ability to add filters. Because, for instance, there might be certain objects that you have, maybe if you have some nighttime footage, we can add a filter that will make that shows better in nighttime. And then
now before we go any farther, Ari, step in back at the UI itself and just tell me what all the little buttons here do, like the little pin over on the right and stuff like that.
Absolutely. So these buttons here allow you to lock all the tags so that nobody else can modify them. This one is essentially is for video tagging. It allows you to empty the frame. This clears all the tags. This goes to the first untagged frame. This moves forward. This moves back. This is the canvas where I can click, drag, and create tags. And I go through it. Now imagine, let's say we've gone through all these images. And we can do this process of exporting. So I'm going to export, and then I'll show you. Well, actually, before I export, let's show you the active learning. So what I did before is I trained a model. It's never been run on these images. It was trained on about 200 other images that I went through this manual process of tagging. And what I can do is show you the power of active learning. Now, this takes a little bit of time to set up to load CNTK. There are other tools that also run faster. I just want you to bear with me. Essentially what I do here is I go to my C drive. I have some pre-trained models here, and you'll see there's one called models. And I just click review. And now we wait essentially between 20 seconds, and while I'm doing that, I'll go show you some additional features of how to get started, or how this model actually, once it's fully trained, got the performance that we needed. And then we'll come back to see this model running up. Actually, look at that. Even faster than I anticipated. So what you can see here is now we have this model. And if you notice, I tagged the first frame, but all the other ones are now pretty much auto-tagged for me. Now, if I see certain things that are a little bit off, I can go in, modify them. But now I have 7 frames that have been auto-tagged for me, for the most part, auto-tagged for me without me having to go manually through and annotate everything. And
right. That process alone just took away easily 75% of the labor that you would have had to have gone through.
Absolutely.
And it's just trying to guess. It's not as good as the final model. It's not as fast as the final model. It's just trying to make your life a little bit nicer.
Absolutely. Well, and here's what's beautiful about it is every time I do this process of exporting and retraining, I get more accurate. And so it means the more I tag and the more I update like this, less manual labor and manual work that I'm going to have to do in the future. But this is
what's the minimum number of tagging images that you think you should have before you start running the this assist?
So it's a very good question. Again, it depends. It's very contextual. It depends a lot on your problem. But what I've seen as a good rule of thumb is for the first, you tag 50 images, train a model, run it on 100, see if that works. Because if you can get the gain from 50, that's amazing. Then go back through on the 100, use that. Then after 100, run it on a series of an additional 100, and each time duplicate to try to minimize, because you should get a stronger model each time. And if you see that the model's not as accurate or not giving you the results that you at first anticipated, then tag just a little bit more data during this process.
Cool.
So now we've gone and we've tagged these 7 images. Now let's say I want to integrate this into my model, retrain my model with this new data.
Wait,
So
now before you do that, let me ask just real quick about the one I'm looking at here. I see the yellow is marked as background instead of as water. Is that?
Yes. Yes. All right. So that what you're seeing here is you'll notice that, but what happens here is that the actual model is actually water. What you're looking at is a dev version of the tool. This won't happen in the production release, essentially because the model that I had pre-trained before has this extra background tag. It swapped some of the coloring. But again, that will be fixed. That you shouldn't see that behavior in the release version, and that will be fixed before this dev branch gets into. But again, very astute observation.
Thank you.
Absolutely.
Did you hear that, Sabrina? Very astute.
Astute, exactly. All right, perfect. So at this point, we're going to go export everything in the model and the framework we want. I'm going to use
Ari, is this assuming that we have CNTK, like the Python API? Are we assuming that we have that?
Yes. So for this case, for training the model, we assume that we have CNTK FastRR and then CNTK installed. But there's actually, when we're doing this active learning, you'll notice there's this feature, I'm really glad you asked this, called remote endpoint. And the way this works, there were some challenges people had setting up their CNTK environment. What this enables me to do, and I'll show you here just a second, is I can actually use a Docker container to do a Docker endpoint either locally or on a DSVM to process all this annotation. So let's say, for example, I'm running on a machine. In this machine, I have a Razor blade that has a really strong GPU. But let's say I'm tagging on a machine that doesn't have a GPU. I can use this reviewer service, and I just send my frames to it, and it will take the model, apply the tags, and give it back and integrate directly in the tool. So again, very easy. You just do Docker pull and just and then you just run the Docker image, and boom, you have a server. You just copy and paste the URL that it sends you right here, and you can do remote reviewing.
So that just means that whoever it is that is doing all the tagging for me doesn't have to have the most powerful machine in the world.
Yes, that's one thing, and it also means that if I have a machine that has Docker on it, it prevents me from having to go through the process of installing CNTK. So if I have CNTK, that's great. Otherwise, I can use this remote active learning to leverage the power of the cloud or leverage Docker, which is also equally amazing.
Cool.
Saves a lot of time. Wow.
Yes, absolutely. Because I don't know how many of you have gone through the CNTK installation process. It's not automated. It can be a little bit of a headache.
Yeah, but this reduces like all the manual configuration that you would need. So yeah, this is pretty great actually.
Absolutely. And so essentially now that we get to this point, we can now export our tags, right? So I'm going to export them in the format for CNTK FastRR CNN. Just click export, and you can see in a matter of seconds, just exported our data. And we'll go into our demo for VOTT, and you'll see we have this SOTA output. Now what's interesting about this is you'll notice when I go into the images, I have this labels TSV, all of our labels, this boxes TXV, and an image, right? Everything here is pre-formatted in the exact data that's needed when I go now to search CNTK, faster, RCNN, docs, right? So now when I go and click the docs here, this is the exact format that they used for their examples. And you'll see that anything, whether it's the Tensorflow API, we have it directly exported in that format too. So what's nice is I can now go through step by step here, and all I have to do is change the reference between this data set that they provide me, the grocery data set, with the new bottles data set that I've generated. And I go through this process and train a model just like I would any other demo model. And I have a model now that can be integrated back in the tool. You can imagine like how much, instead of me now having to write scripts and understand what's the format and every single thing for every single different framework, now I have a streamlined process of minimizing the amount of annotation work and the amount of processing work that I have to do as a developer or data scientist. So one additional treat that I have here is we also have the ability, if you don't have CNTK installed and you don't have you don't have access to or essentially you don't want to deal with spinning up a DSVM or the state-of-the-art GPU. One of the things we also provide support for is exporting to the Custom Vision Service. So essentially all you have to do is you type in whatever your training key is. And when I do that, export. Now I'm not actually going to put in my real training key because that would be silly in a live podcast, but what I will show you is a model with the Custom Vision Service, which is customvision.ai. And I'll show a process where I actually went through this process of actually having a trained model. So here, just 1 second, bear with me as Custom Vision Service loads.
One of the models I didn't see was the Onyx model. Is that where we're going with Custom Vision?
So that is a good question. That is a question for the Custom Vision team. Currently, you can export, I believe, Onyx for classification, but for object detection, and it's still in prototype mode. It's still in beta. They're working and they're iterating on it. But what's really nice here is you can see these are all the same tags that I exported from my tool. I see them in the object detection service. I can go through it. I can train. I've already gone and trained. And then what's really nice, without a single line of code, I can go through, browse locally, and we'll go back through the example that we had before. Again, this example is a little bit overfit because you saw that we just tagged this stuff. But it shows how quickly you can put these things into production.
And by overfit, what you mean is we've used all the images we have and tagged them all perfectly, and then use those same images to test it.
Yes, and you can see if I increase the probability threshold, that noise in the bottom disappears, and absolutely, exactly what you said. We're able to take a real model and apply it without writing a single object detection model, without writing a single line of code. And what we're in the process of doing in a future iteration is also providing the active learning feedback loop from this service directly back into VOTT. So at some point, it just becomes an engineering problem. It's not even a deep learning problem for me anymore if I'm just a standard engineer. So
can you use this? Really can you use this with videos on the Custom Vision side, or is it just strictly?
So for the Custom Vision side, it's strictly images. But actually, that's what's really nice is I can go through, and I'll open a new video. So I'm going to go through.
Nice. And what's a video other than another kind of directory full of images?
Exactly. and that's what's really beautiful here is I can go through. We just put in however many frames we want to extract per second. We have this ability to either copy the last frame over. We have actually built-in tracking uses Camshift, so it's not always perfect, but sometimes it can help. And I'll put in, let's say, car, right? So we're going to detect. I go in, I label cars, and I go in frame by frame.
Mm-hmm.
This is what you see here is the duplication of the frame from the previous image. Okay, let me like that, drag this, drag it over, right? And in the same way that I did that before, now I can do export tags, Custom Vision Service, and boom, I can now train this model and have the same feedback loop on video, even though that's something that isn't directly supported at this time by the Custom Vision Service. So that's a unique feature that we have, and hopefully we'll see in the future on both sides.
It's a neat hack, actually. I like this.
Yeah, so again, and we can go back. So just to recap in terms of how we use this model.
Mm-hmm.
So I have this notebook here, and again, all these notebooks here for object detection, you can find them on my GitHub page. I'll quickly bring that up for anybody who's interested, and I'm sure we'll have the links later on. CV workshop, and we have all the different tutorials bringing you through, showing you exactly step by step what this process was like and how we got these results. And you can see at the end here, essentially what we did is we used this bottle detector here to identify where all the bottles are. And we're able then to tell whether something's valid or invalid by using a simple heuristic. Essentially what we do is we look at the top corner for each of the objects and the bottom corner for each of the objects, right? And we look for for each of what we want for each class is the smallest top corner. What does that allow us to do? Well, if we have the smallest top corner for each of the objects, we can first determine that the smallest top corner for soda is on top of the smallest top corner for juice, which is on top of the smallest top corner for water. And now we have a higher policy hierarchy of our ordering. Then we look at what's the largest bottom right corner for each class. Essentially what that gives us is it gives us this box. So now we can see, based on that box, now that is everything in that box on the top soda, is everything in the box water, is everything in that box juice, and that tells us that now that we know that the soda's at the top, is at the top, right? That this is the top soda. It shows us, okay, when we look at this box between the top soda, the bottom soda here, that this juice and this water are in that field of vision.
Nice. So you're not even looking. This isn't a vision issue anymore. Now this is a data issue. Now a developer who doesn't understand vision at all can come in and perfect the policy to make sure that everything's where it needs to be based on the data that's been returned back.
Absolutely. And you can see here for this data set that we built out, we got perfect results, whereas before, when we took the same data set and we applied it for classification, and let me pull that up here in my examples for you. Just one second. Yep, here at the bottom, you can see that we also got good results, but not good enough. And so that's really the power of this kind of system, is it allows you to not only do object detection, but use object detection in new and unique ways that allow us to classify things, complex and subtle features that we wouldn't have been able to classify otherwise.
All right, Ari, take us back to the chocolate company. How'd it work for them?
So for them, they've taken this. They're working with a vendor called Smart Business. And again, now what we do after we've unblocked, we give them the handoff, and now it's their responsibility to take this solution that's unblocked them and partner with it to take it to production. And that's where they're going. And again, it's really good. We got some really good feedback from them, and it's good to see where they're going with this.
What's beautiful about this is, like, it's up to now the developer that's listening and watching right now to not think, oh, this is a chocolate solution, when that's not what it is at all. This is not a soda solution either. This is a vision solution. These are just our simple examples. And now they need to take whatever their domain is and apply it. And the nice thing is, because we did it for chocolate, because we did it for sodas, we were able to also make it so that all the tooling made it easier because we don't like to work hard either.
Absolutely. And that's the beauty of what we do on our team is after we've developed this, we ship when we share. So we've made sure that everything's open sourced, everything's documented, and so that people can go out to GitHub, Microsoft/VOTT, and just get started.
That's pretty sweet. What do you think, Sabrina? Pretty cool?
No, I think this is amazing. I can totally see so many use cases for this, and saves a lot of time and removes a lot of the manual effort. That's what software engineers need, right?
And how cool it is that they're ahead of the service. They're like, oh, okay, they're going to have this feature someday, so we'll go ahead and support it now. That's
Which is great, yeah.
Yeah, and it's all Electron. I think that's valuable, right? Because this isn't specifically for Windows users. This isn't specifically for Mac users. It's just for developers.
Exactly. And again, and that's the last thing that I wanted to finish up on. Exactly what you said. Everything's Electron. All the components are organized and reusable. And if you look here, this is what I was talking about. The way that we support faster RCNN or Custom Vision or any of these different exporter or reviewer formats, we have a simple interface. And as long as you give these outputs with your code and these inputs with this set of code, then you're set. You can integrate with whatever model you want, or any exporting format as well.
That's beautiful. All right, well, it's easy enough to find github.com/Microsoft/VOTT, VOTT. That's the visual object tagging tool. Ari, unbelievably easy, man, taking such a hideous job, and making it, well, let's just say tolerable.
Thank you. I really appreciate it, and I'm looking forward to seeing what the community does with this great work.
All right, cool. Thanks for being on the show.
Absolutely.
Thanks, Ari.
Thank you guys for having me.
Bye-bye.
Take care.